my infamous eye roll.
Let it be what they say. Yeah, I'll try to keep a tame mouth today.
You're not by Jacob, so it should work out well. All right.
Yeah, now he's in yelling distance.
All right, 11.1, systems of linear equations. Okay, there are two algebraic ways of solving systems. There's elimination and there's substitution. Okay, I prefer elimination. Okay, but there are certain instances where substitution is the way to go. Okay, so given each systems of equations, determine the best way to solve each, then solve. Okay, so this first one is an example of when substitution is best. The reason that substitution is best is because you have a y equals already. If you have a y equals, that means you're going to take what y equals and you're going to plug it in for y in the other equation. Okay, so y equals this, so we're going to plug that in for y here. So you get x plus negative 2x plus 4 squared equals 5. So this is the substitution method. You are plugging in one variable, and then you're going to simplify it. Does everyone understand why it's squared? Okay. So now we need to square this. When you square it, it means that you have two of them. And that you have to multiply that out. Negative 2x times negative 2x is a positive 4x squared. Negative 2 times negative 4 is negative 8x. 4 times negative 2 is negative 8x. 4 times 4 is 16. And that would equal 5. What this results in then is we have 4x squared. I have an x and then two negative 8x's. And so that ends up being a negative 15x plus 16 equals 5. You need to get everything on one side, so I'm going to subtract 5. So 4x squared minus 15x plus 11 is going to end up equaling 0. What do we need to use? The chart method. You get 44 and negative 15. A times C, right? So that would be a negative 4 times negative 11. Negative 4 plus negative 11 is negative 15. What do you have to do next, which is the most common thing? Divide by A. So you have to divide by 4. So you get negative 1 and negative 11 fourths, which ends up being x minus 1, 4x minus 11 equals 0. So what are your two x values?
1
and 11 fourths.
When do you switch them
You should never switch them till after you pull them out of parentheses.
As long as you put them in parentheses,
Yep.
for everything.
Mm-hmm. So it goes into parentheses. Once it comes back out, now it's not. Okay, because you're looking for what makes this 0 and what makes this 0. That's what you're looking for. So if x is 1, we have to figure out what y is. So if x is 1, and I can just plug that in here to this y equals 1, what do I get my value of y is? 2. And if x is 11 fourths, you'd plug that in. You get negative 22 fourths, which I think is negative 11 halves, yeah, which is negative 5.5. So by plugging in 11 fourths here, this is negative 5.5. What's negative 5.5 plus 4? Negative 1.5. So if you're using the substitution method, you should always plug it into the one that was already solved for the variable. Okay, so that's why I plugged it into this one, because it was already y equals.
So you plug in the x values we have?
Yep. So you plug those in for x. You have 2 x values and 2 y values because it was a y squared. Okay, so what that means is that this is a parabola going sideways. This is a line, so it's going to hit in 2 locations.
Yeah, whatever.
Mm-hmm.
So you don't need to put both x values in both equations, just one.
Just one of them. Yep. And you usually want to do it to the substitution one.
Okay.
Other questions on that one? Yep. Yep. So a solution to a system is the 2 locations where they intersect. So where you intersect is going to be a point. Any other questions? All right, so when it is y equals, that's hinting that you should use substitution. Do any of these other ones have y equals?
No, but you can make them.
You could, but instead what I would do is I would use elimination. Okay, so what elimination is you're going to multiply one of your equations by a number, or both of them by a number, so that the coefficients on one of your letters is the same, so that they cancel each other out. Okay, so for example, I'm going to multiply this by 2, because if I multiply this one by 2, I have a 4x and a negative 4x. Do you guys see that? So this is called elimination.
So you want to get them opposite of each other?
Yep. So I'm going to times this one by 2. So when I times that one by 2, I get 4x plus 2y equals 10. So that 2 goes to all parts of the problem. And then this is negative 4x plus 6y equals negative 2. I didn't multiply that second one by anything. Then you add these vertically. So what's 4x minus 4x? 0. So those 2 cancel. So I get 8y equals 10 minus 2 is 8. Divide by 8. What is my y value? 1. And then after you get your y value in one of these, you need to pick one of these above. Okay, and I usually go back to the initial ones because they're smaller. Okay, so you need to pick one of these to plug that y value into so you can get your x value. Which one, based on the numbers in them, do you think you should plug it into? The first one, because those numbers are smaller, right? So you have 2x, and then it'd be plus 1, because I'm plugging in my y equals 1 in for y, equals 5. So you would subtract 1. It means 2x equals 4. Divide by 2. It means x is 2. And so these 2 equations are going to intersect at the point 2, 1, or when x is 1 and y, or x is 2 and y is 1.
So how come the other one has 2?
Because it was squared.
Oh.
Yeah. So since this was, neither of them were squared, there's only going to be one intersection point because they're straight lines. Okay? All right, so there are some tricks, like tricky ones to this that we need to talk about, and that occurs in these 2 here. Yes?
If it's squared, would it be better you use the substitution?
Yes. Yep. And usually they hint at it anyways with the y equals. Yeah.
Do you have to ever use elimination, like where substitution would not work?
Both ones always work.
Both of them.
I just feel like elimination is easier. But that's my own personal preference. But both will always work. Any other questions? All right, so let's do these tricky ones, these shyster ones at the bottom. Okay, so this one, what would you multiply this top by so that things would cancel for your x's? Good, so I'm going to times this by -2. Okay, so my top then I have -4x minus 2y equals -10. I have 4x plus 2y equals 8 for the bottom. What do you notice happens with your x's and your y's? They both cancel, and you get 0 on this side equals -2 on that side. If your numbers don't equal, it means that the two lines are parallel. So you have two lines going like this, or some other direction, but you have two lines that are parallel. And so this one would be no solutions. They never intersect, so there's not a point that you can find to solve this system. Your two lines would be parallel. No, it's perpendicular.
Okay, yeah.
It's perpendicular. Yep. No, parallel means they have the same slope. So if you solve this one for y, and you moved your x's over, they're both going to have a -2x. So -2 is both of their slopes. All right. This one's another one. You would times this by -2 as well. So you get -4x minus 2y equals -10. 4x plus 2y equals +10. So you get 0 equals 0 on this one. They're the exact same line. Okay, so that's one line with another line on top of it. So how many solutions, if it's the exact same line, at how many points do they intersect? All of them, infinitely many. Okay, so it's infinitely many solutions. You could. Okay, it also may say all real solutions. It's every solution that you could come up with for x, they're going to have the same answer. So how do you guys feel about substitution and elimination? Do you remember doing that at some point in your past? No? Ooh. All right. Solving systems in 3 variables. Okay? Solving systems in 3 variables, the only way I'm going to teach you is the elimination method for this. Okay? So what you do is you choose 2 of the equations and get rid of one of your variables using elimination. Okay? Then you use the unused one and one of the equations you use in step 1 to get rid of the same variable from step 1. Then using elimination, you use these 2 new equations to solve for one variable, and then you start going backwards, plugging that in to find the other 2 variables. Okay, so there's going to be a lot of elimination going on here. You have to do 3 eliminations to get one answer, and then work your way backwards to get some other ones. Okay, you may have never seen this before. You would have done it in intermediate algebra. Okay? So the first thing that I'm going to do is I'm going to pick 2, and I'm going to use elimination on it to get rid of them. So in this one, I'm going to choose these 2. And the reason for that is this one's super simple. Do you guys see how it's very simple? This one, not so much. Okay, so I'm going to choose the most simple one and one of the other equations. Okay? Now, on this, I need to use elimination. What variable would you guys like to eliminate? It doesn't matter which one we choose. We just have to pick x, y, or z. You want to choose x. So what do we need to multiply this by so we can get rid of our x's? -4. So I'm going to times this by -4. So from that, you would get negative 4x minus 4y plus 4z equals 4. And then you have 4x minus 3y plus 2z equals 16. And now I'm going to use elimination. These two cancel. I get negative 7y plus 6z must equal 20. Okay? Then you need to use your unused one and one of these to do elimination again on the same variable. So I'm going to I have to use this one for sure, but I'm going to choose this top one because it's the most simple. We have to eliminate our x's, so what do we have to multiply this top one by? Negative 2. So I'm going to multiply this top one by negative 2. So that gets me negative 2x minus 2y plus 2z equals 2. And now I'm rewriting that bottom one. 2x minus 2y minus 3z equals 5. X's cancel. I have negative 4y minus z must equal 7. Was anyone else in intermediate algebra last semester or just Jen?
Last year.
Last year? Do you remember doing this last year? No? Okay. All right. Now, we have to eliminate either y or z. I would recommend doing z because I have a single z here, so if I multiply this by 6, do you guys see how my z's would cancel? So I'm going to eliminate z, and I'm going to find what y is. So I'm going to keep this one the same, negative 7y plus 6z equals 20. I'm going to take this one and times it by 6. So I get negative 24y minus 6z equals 42 that I'm solving. You guys are checking my addition and subtraction while we go along here, right? Yeah. Okay. Yep, so we're going to add them. Negative 7 and negative 24 is negative 31y's. The z's cancel. So that equals 62. So you're going to divide by negative 31. So y is a negative 2, correct? Okay. Now, you're going to start working backwards. So we have y. We're going to start working backwards, plugging in to find our x and our z. Okay, so we found y is negative 2. So now we're going to pick one of these to plug y into to find our z. I would recommend this one, right? This one's more simple. So I'm going to take my y and I'm going to plug it in here. So I get negative 4 times negative 2 minus z equals 7. Negative 4 times negative 2 is 8 minus z equals 7. Subtracting 8, it means negative z equals negative 1, which means z is just 1, correct? So we have y and z now, correct? Now that we have y and z, now we're going to pick one of these to plug these into so we can find x. These three. Because we only had what y equaled, and so if we plug y in, we don't have the ability to find like one letter by itself. So that's why we take this and we plug it in here or here, because then we have one letter by itself by plugging this in. So we have z is 1. I'm going to choose this first one, right? So then we have x minus 2 minus 1 equals negative 1. So that's x minus 3 equals negative 1. So x is 2. So we have 2, negative 2, and 1 as our three solutions to this equation. Okay? So, first you eliminate one of your variables by choosing 2, and then by using the unused one and your easy one. Once you get it down to 2, you take those 2, and you eliminate one of those variables. Now you're going to have one that works. You'll take that and plug it into one of these to get another letter, and you take both of those and pick your easiest one to get your third letter. Okay? So, yep. All right. Do you want to do another one? No. You guys feel okay about the 3 elimination-wise? So I want you to do page 714, 17 through 53. Do the first column. Okay, so there's usually 2 or 3 columns. You're just doing all the problems in the first column. Does that make sense? You're not doing odds or evens. You're taking that first column and just doing those. Sound good? Okay.